topic is Coulomb's inverse square law. Coulomb's inverse square law. Coulomb's inverse square law. What is Coulomb's inverse square law? First of all, we are going towards previous class because there is a very related concept are there. In gravitation, we know that universal law of gravitation. Universal law of gravitation is act between two different masses, and this one force, and there is an m1 mass and m2 mass are separated at a certain distance. Then the force of attraction are act between these two masses, but there is no nature now. In related to electrostate, Coulomb's inverse square law, then there is a nature of charge is more important. If both the charges are positive, they repel to each other. If both has their negative charge, again they repel to each other. And another time, one positive and one more negative, then they attract to each other. It means there isn't some differences are there, force of repulsion and force of attraction. Both the forces are in Coulomb's inverse square law, but is in respect of Coulomb's gravitational law, it is an only force of attraction, but Coulomb's inverse square law and electrostatic law is force of attraction or repulsion. And this is depend upon the nature of the charges. Is in this condition, again we see that this charge is Q1, this charge is Q2. And the distance between these two charges, suppose like that, R. Then we are going towards its statement first of all, and that time this is first, this is second. There is an important conclusion is direction factor. On first, second is applied, it means F12. On second, first is applied to 1. On second, first is applied to 1. On first, second is applied 1 2. Same as 1 2. Same as 2 1. This is vector formation. These are the vector form F12 and F21. It means we say that both the conditions or the force of attraction or repulsion, both sides, both conditions, these forces are acting in opposite direction. How it is? Like the first case, please see. Is in this condition both the forces are acting in opposite direction? Yes, and same as force of attraction time, again they act in opposite direction. It means the inverse square law or the Coulomb's inverse square law follow the Newton's third law of motion. Every action there is an equal and opposite reaction. It means on that one applying similar force by this body, on this charge another same time applying the same force, but is it opposite direction. We drive it and we prove it in Coulomb's inverse square law, verify Newton's third law of motion. Clear? And that time we drive the statement of Coulomb's inverse square law. What is Coulomb's inverse square law? Statement. That statement is when two charges Q1 and Q2, I repeat, when two charges Q1 and Q2 are placed at a distance of R, then the force of attraction or repulsion, is directly proportional to the product of these charges. This is statement 1. And inversely proportional to the square of the distance between them. On behalf of these two conclusions, number 1 and 2, we taken out F is directly proportional Q1 Q2 upon R square, and directly proportional sign is always moved by the constant. Then F is equal to K Q1 Q2 upon R square, and force is always measured in Newton in SI system, and this is and force. But what is K? K is very important. There is electrostatic constant, and K is there 1 upon 4 pi epsilon naught. K is 1 upon 4 pi epsilon naught, and epsilon naught is called permittivity of free space. Permittivity of space or free space. Free space. That's concept epsilon naught. What is the value of this one, and what about the unit? We write now this side again. That's value is epsilon naught is 8.85 into 10 to the power minus 12. This is the value of permittivity. And again, in the next para, we find out the value of K is in this part. Please write down each and everything in your copies, please. After that, we remove this diagram. Okay. There is. Put about this one. Then put the value. F is equal to, the formula is K is 1 upon 4 pi epsilon naught. Q1, Q2 upon R square is in Newton. We know that. And the value of this 1 upon 4 pi epsilon naught is equal to 1 upon 4. The value of pi is 3.14 and epsilon naught is 8.85 10 to the power minus 12, and the numeric value taken out 9 into 10 to the power 9, and that's the final answer is F is equal to 9 into 10 to the power 9 Q1 Q2 upon R square, and unit is Newton. That's simple. This is Coulomb's inverse square law. Is in this condition, on behalf of this formula, we define something very important, 1 Coulomb charge. But first of all, we are going to work in CCS system also. But in CCS system, we know that there is a charge cannot be explained. That system basic name is ESU system, and the name is, where is the CGS system or ESU system, F is equal to, that's K value is 1, K lies 1 is in this condition, then F is 1 Q1 Q2 upon R square, and unit Newton is change out is in form of diet. That's the unit in CGS system, and this is Coulomb's inverse square law. On the basis of this Coulomb's inverse square law, we explain another things by later on. Please write now. There is defined, very important. 1 Coulomb. Define this term. Define. 1 Coulomb charge. What do you understand by 1 Coulomb charge? We discussed that so many times. 1 identified. Otherwise, आपको बुक से रटना पड़ेगा. You create that self. खुद अपने आप ड्राइव करो, खुद पैदा कर सकते हो, खुद ड्राइव करके अपने आप अपना एक न्यू डायमेंशंस डेवलप करोगे. Easiest formations, right? F is equal to 9 into 10 to the power 9 Q1 Q2 upon R square. It is measured in Newton. Then all the values put together and we define what is 1 Coulomb charge. Please see on that side. If Q1 is equal to Q2 is equal to Q, and we are taken as similar charges. Similar charge. Okay? That why we are using similar means force of repulsion. Okay? Repulsion. And a repulsive force. That's repulsive because both are similar charges. And R is equal to 1 meter. And this is Q and this is 1 meter put. But there is another numeric value. Then eliminate it. F is 9 into 10 to the power of 9 Newton. All these value put in this formula, then you define what is 1 Coulomb right now. 9 into 10 to the power 9 F. Again 9 into 10 to the power 9. Q1 into Q2 is Q. It means Q square. upon 1 meter square. Correct? Cancel. Then Q square is equal to plus 1 and then Q is equal to plus minus 1. This is 1 Coulomb charge. What is the definition of 1 Coulomb charge? Please see on board again. When two equal and similar charges, there is equal. When two equal and similar charges are kept at a distance of 1 meter, and experience a force of repulsion, 9 into 10 to the power 9 Newton, then charge is called 1 Coulomb charge. I repeat again, please see. When two equal and similar charges, because they are similar, when two equal and similar charges are kept at a distance of 1 meter and experience a force of repulsion 9 into 10 to the power 9 Newton, then each charge is called 1 Coulomb charge. This is the definition of 1 Coulomb charge, and we define on behalf of this one. Another part related to that topic we are discussing next part. Okay, thank you.